Hi, everybody. Last Thursday, I assigned a couple of problems that I asked you to think about and then try and then upload your answers to the Google Classroom. So, thank you for doing that. I looked over your work, however complete or incomplete it was. I appreciate you taking the time to at least read the problems and think about something. I thought, though, after looking through your work, that a little talk through might be helpful. So, that's what I'm going to do now. Is I'm going to talk through the work and the solutions to those two problems from last Thursday. All right, so problem one talked about a computer screensaver that shows two circles that start as dots and expand outward. So at the instant that the first circle has a radius of 9 centimeters, the radius is increasing at a rate of, this should be 3 over 2 centimeters squared, or centimeters per second, I mean. So this 32 should be 3 over 2. Find the rate at which the area of the circle is changing at that instant. So I have some errors over here, but just work with me. I didn't feel like downloading and re-uploading my work again. All right, so circle is the first word that jumps out at me. I know that for the circle, the area's formula is pi r squared, and the circumference is equal to pi times 2r. Maybe I'll use one of these, maybe I'll use both, maybe I'll use none, but I have to try something. Circle. Area formula, circumference formula. I've known that for years. Now, what are they asking me to find? Find the rate at which the area is changing. So the rate at which the area is changing will be the derivative of the area formula. So the derivative of A would be just dA dt. So the derivative of the area with respect to time is equal to the derivative of pi. Well, that's just a constant. It's hanging out for good. The derivative of r squared is going to be 2r. And then I took that derivative of the radius with respect to time again. So that's where this expression came from. So that's my formula that I'll use to find the rate at which the area is changing. And then I need to plug in a 9 for the radius because we know for sure that when the radius is 9, the rate of increase is 3 over 2 centimeters. This should be 3 over 2. I plugged it in correctly, 3 over 2 right here. Blah, 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 a bunch of simplification, and I'm down to 27 pi. It also asked me to indicate the units of measure, so I said centimeters squared per second. So how is the area changing with respect to time? Remember, area is going to be centimeters squared for a circle, this circle specifically, and then the time frame that we're looking at is in terms of seconds. So that's the correct answer for part A. Now for part B, it says the radius of the first circle is modeled by this function over the time interval from 0 to 6, where W of t is measured in centimeters and t is measured in seconds. Over here in this function, it just didn't copy well. This should be e to the negative 0.5 t. Now, at what time t is the radius of the circle, at what value of time t is the radius of the circle increasing at a rate of 3 centimeters per second? Okay, well, anyway, I started with a function that was given, and that, remember, is the function for radius. Why they gave it to us in terms of w of t, I have no idea. I crossed it out. I'm calling it r. So the question is, at what time of t is the radius increasing? So is the radius changing at a rate of 3 centimeters per second? So that's what I want to know. When, at what time, what t is dr dt equal to 3? So I did the derivative of this function. The derivative of r would be dr dt. The derivative of 12 would be 0 because it's a constant. The derivative of negative 12e to the negative 0.5t. Remember that the derivative of an e is just whatever it is, but you have to do a little chain rule. Think about what's the derivative of your exponent? Well, negative 0.5. So simplifying this, negative 12 times negative a half will give me 6. E to that, still the same exponent. I divide by 6 and I get 0.5. Algebra tells me if I take the natural log of both sides, that will undo the e. And the natural log of 0.5 will be a calculator punch, divide it by negative 0.5, and I get 1.386 seconds. Round to the nearest three decimal places, and you should be good to go. All right, so now before you walk away, is that time in the interval from 0 to 6? Yep. Are you labeled appropriately? Remember, my rate was centimeters per second, so my time is going to be some number of seconds. So that all looks good. I think we're done there. And then the final part of this question says the rate of change of the radius of a second circle is given by this function. So, okay, whoa, function. the function that's given to me is actually drdt. It's the rate function. It's not a function that's going to give me the radius. It's going to give me the amount of change that's happening per time of the radius. Now the question is, based on this model, by how many centimeters does the radius of the second circle increase from 0 to 3? So, what I'm thinking here is accumulation. How many centimeters of radius is being accumulated as the time passes? So, as the circle expands, how much is your radius growing? So, I did an accumulator function. I'm doing the antiderivative. Antiderivative is accumulation. So I want to do the antiderivative of the function from 0 to 3 dt. Now, you're going to be able to use your calculator on this. So if you plug it in your calculator, you're going to get 3 centimeters. Perfect. Or you could do it by hand. I wouldn't waste your time though. You could do the antiderivative, all those antiderivative rules, and then just evaluate it from 0 to 3. Whoops. Back here on this problem, Alyssa, I noticed that you had a great accumulator function set up. You came up with like 14 something. I just wasn't quite sure how that happened. So either do the antiderivative or do math 9 on your calculator and come up with that 3. All right, lastly, the second question, the last question was this question about water being pumped into an underground tank. So I know for sure that water is being pumped in at a rate of 8 gallons per minute. Water's coming out of the tank at a rate of the square root of t plus 1 gallons per minute. And then this is happening for 120 minutes, or like, what would that be? 2 hours. They also tell us that when we started counting time, the tank had 30 gallons of water in it. The question is, how many gallons of water are in the tank at time t equals 3 minutes? Again, I'm thinking accumulation. How many gallons of water are accumulating in this tank? If you think accumulation, you're thinking antiderivative. So begin, how much comes in, how much goes out, and then how many gallons are in the tank at the 3-minute mark? Well, I'm not going to do any accumulating here with this 30 because that was just my beginning, like initial condition or initial value. Accumulate from 0 to 3 of 8. Accumulate from 0 to 3 of the square root of t plus 1 dt. And whoops, that will give you 49.333 gallons. All of this could be done by, or these two accumulator functions or antiderivatives could be done by hand, but I'm really just at this point, plug it in your calculator, strongly encouraging you to do that. All right, so I hope that helped. The AP exams less than 4 weeks away now, I guess like 3 weeks and 5 days or something. I've been getting lots of information from College Board. At this point, all I can say is that it's really important that you not cheat. So be conscientious of what you're putting on social media, what you are, I don't know where else you would be putting information, but according to a webinar I watched last night, they've already caught one student attempting or planning on cheating on the AP physics exam, and College Board is already starting to make his life miserable. I don't know what that means. I don't know what that looks like. I don't know how that happens, but I would just hate for you to be wrongly accused of cheating. I don't know how you would do that. But so anyway, just be careful about what you're saying. Like on Twitter or whatever. I just want you to do something the day of the exam. They also really stressed last night that you don't have to complete every part of either of the two questions to get a 5. Just try something, and chances are you're going to be pleasantly surprised by your score. All right, so that takes care of that. Please be keeping up with the daily College Board videos that I'm posting, and then, plugging away at that work. All right, I really miss you guys. I hope you're all doing well. Take care.